Hi, this is a single degree of freedom system oscillation problem level 2. Here I'm trying to implement an integration scheme. This is Euler integration. I have some Python code that I wanted to check against what I'm doing in Blender, and I ran the Euler integration, the improved Euler integration, and then I also calculated the exact solution. And here are the parameters of the mass spring damper system. The delta T is 0.01 seconds. And then I calculate each separately. X is the Euler integration, XX is the improved Euler integration, and then U is the exact solution. And I plot out the results here, and you can see that the Euler integration is a little bit off from the exact solution, but the improved Euler integration is pretty much dead on with that kind of time increment. Now we move to Blender, and here is the geometry node setup for the green dot, which is the exact solution. And as I scan through this, you'll probably recognize the exact solution from one of the previous videos. And another link I have in the description is to this Ping-Pong method. And I don't know if this is the first person to do it or if this is just the first one that I know of. But it's a very clever method, and if you go through this, if you go through his tutorial, which is really more a walkthrough of what he did, but it's a really interesting way to use Blender. And so I implemented the Euler method, which is the red dot, and you can see the results. I'm plotting it out here. I had to adjust the scale of the outputs because the scale on the plot that came out of Python is not uniform on each axis. And of course it doesn't really match what's being output by Blender, so there's some scaling that was taken care of. But I'll go into this in a little more detail in another video soon.